In this problem, we are going to convert rectangular coordinates to polar coordinates. Rectangular coordinates are the coordinates you plot on a coordinate plane, also known as the Cartesian plane. And in the Cartesian plane, we typically identify the location of each point with coordinates that denote where the point is horizontally and vertically with respect to the origin. Polar coordinates are another method of denoting the location of a point on a plane. We start with a point we call the origin, same as rectangular coordinates, but this time instead, for polar coordinates, we use another method of denoting them. For polar coordinates, we donate them as r data. So r stands for radial coordinates, and then data stands for the angular coordinate. So if we draw a coordinate plane, then the radial coordinate r, we can take an example point A. And we can call the coordinates of A and r data. So the distance from this point A to the origin is known as r. And then this angle is theta. Now, to measure the angle, it is the same way to measure an angle on a unit circle. This means that if we call these angles 0 degrees, 90 degrees, 180 degrees, 270 degrees, we go counterclockwise starting from 0. So this means that a point with theta equal to 0 degrees is directly to the right of the origin. A point with theta equal to 90 degrees is directly above the origin. And a point with theta equal to 180 degrees is directly to the left of the origin, and so on. So, using this information, we can convert rectangular coordinates to polar coordinates. Let's start with 0, negative 3. So, if we draw a graph, well, 0, negative 3, we can call this point negative 3. Well, the distance from the origin is 3 units. So, r equals to 3. And then the angle will be 270 degrees because it's 3/4 of a whole circle. So the polar coordinates of this one will just be 3, 270 degrees. Then, for 5, 5, we can use the same method. So we connect the point with the origin to find r. Now to find r, we have to use the Pythagorean theorem this time. So if you draw a perpendicular line down, and then construct a right triangle, then, well, since these two lines are equal, this means that this is an isosceles right triangle. So if this leg is 5 and this leg is also 5, r equals to 5 square root 2 by the ratios of the side lengths. And then, in the isosceles right triangle, this angle equals to 45 degrees. This will mean that polar coordinates are 5 square root 2, 45 degrees. Now, for the last one, we can call this point as negative 2 square root 3, negative 6. Then, once again, we can construct a right triangle. So, connecting this point to the origin, so this equals to r, and then draw a perpendicular line and construct the right triangle. So know that this is negative 2 square root 3 to negative 6. So notice that these two legs in the right triangle are in the ratio of 1 to square root 3. This means that this is a 30, 60, 90 right triangle because it satisfies the ratios of the side lengths. So then the final ratio can be used to calculate the length of r. The ratio of the sides in a 30, 60, 90 right triangle is 1 to square root 3 to 2. So r will equal to negative 2 times square root 3 times 2. So it will equal to negative 4 square root 3. So we have 4 square root 3 here. These are all positive because we're just measuring the distance. And then for the angle, well, we know that this by the 30, 60, 90 right triangle equals to 60. And then you have to add 60 to 180. So they'll equal to 240 degrees. And that is how you convert rectangular coordinates to polar coordinates.